Okay, this is section 2.3 for finite math. Okay, I think you're going to enjoy this section. Not terribly difficult. We're going to talk about matrices, which I know we've already done. But we've talked about it to use Gaussian elimination. There's other concepts that you can use with matrices to solve some problems. So first of all, a matrix is a rectangular array or arrangement. In math, we say it's an array of numbers. All the data is arranged in rows and columns, and we use them to help organize data and perform operations on the data as a whole, not just multiplying, say, two numbers, but multiplying a whole group of data. Okay, let's talk about dimensions. Dimensions are basically the number of rows and number of columns. So when we go across here, these are rows. So that matrix has 2 rows. It also has 3 columns. So 2 rows, 3 columns. This would be a 2x3 matrix. On this example, you've got 1, 2, 3, 4 rows. You get 2 columns. So that's a 4x2. And then down here, I've got 3 rows and 4 columns. Okay, dimensions aren't terribly difficult. Okay, let's talk about operations on matrices. Here's an example of addition. I have a 2x2 and a 2x2. You need to know this. Whenever you add, you got to have the same dimensions. This pencil isn't working real good. I'm going to switch. Got to have the same dimensions. So when you look at it, this matrix here is a 2x2, 2 rows, 2 columns. This is a 2x2. They have to be the same. Both of them are 2x2. Now to actually add, you add the corresponding elements. So I got a 2 here. Well, let's just say that's the upper left. 5 is upper left here. So if 2 plus 5 gives you 7. Then when I go here, I got 3 and 2. That's the upper right. 3 plus 2 gives you 5. Lower left, I got 0 plus -1, which is -1. And then lower right, I got 4 plus 8 gives you 12. That's addition. You add the corresponding elements. That's all you have to do. Again, very simple. Okay. And then you got subtraction. Same thing. Upper left, upper left. So I got 2 minus 5 is -3. 3 minus 2 gives you 1. 0 minus a negative. Minus a negative becomes plus, so 0 plus 1 is 1. And 4 minus 8 is -4. Okay, again, very simple. Also with subtraction, just like addition, you got to have the same dimensions. Okay, now here's another concept, and this is called scalar multiplication. It's different than multiplication. I'll show you multiplication here in a second. With scalar multiplication, you're going to have a number on the outside. This is like distributive property. Whatever number's on the outside, you're going to take times each number on the inside. So you take 4 times 2 gives you 8. 4 times 3 gives you 12. 4 times 0 down here is 0, and 4 times 4 gives you 16. That's scalar multiplication. You don't have to worry about dimensions because you only have the one matrix. Okay, so we've done addition, subtraction, multiplication, scalar multiplication. Okay, and now we're going to do multiplication. Now this is the tough one. Now I've got to point out, when you multiply 2 matrices together, you need to check the dimensions. So this one is a 2x2, and that's a 2x2. The inside two always have to be the same. If they're not, you can't multiply it. The outside two will give you the answer. So if I look at the outside two here, that tells me I'm going to have a 2 by 2 for the answer. Now, I'm going to do this, and just kind of bear with me. It's going to be a 2 by 2, so 2 rows, 2 columns, 4 elements. So I'm just going to put this in here. These are like placeholders. I'm making them kind of light so you'll see them, but not get all excited about it. Okay, so we know that we're going to have, this is row 1 and row 2, and column 1, column 2, if you're talking about rows and columns. Okay, when you multiply, you take the rows of the first one times the columns of the second one. Okay, so just do this. Hope you can see there's row 1, there's row 2 of the first one. We take the rows of the first matrix times the columns of the second matrix. This is going to be different. This isn't just taking, for example, 1 times 5. That doesn't work. You're going to take this whole row times this whole column. So if you're looking, the first element here is 1. The first element here is 5. So I'm going to take 1 times 5, and I'm going to add that to 2 times 7. So 1 times 5 is 5. 2 times 7 is 14. When I come over here, I had 5 plus 14. That number is going to be 19. So that's the first one. That was 1 times 5 and 2 times 7. I don't know how well that's showing up. Okay. To get this element, that's the first row and a second column. So I'm going to take the first row here times the second column there. So the first number is a 1, the first number is a 6. So I'm going to take 1 times 6 plus 2 times 8. I knew I was going to run out of room. So 1 times 6 is 6, 2 times 8 is 16, 6 plus 16 is 22. We'll go back to this here. Okay, so this element is in the second row, first column. So that means I'm going to take the second row here and the first column there. So the first number here is a 3, first number there is a 5. So I'm going to take 3 times 5 plus 4 times 7. So 3 times 5 is 15, 4 times 7 is 28. So 15 and 28 is going to give me 43 over here. Okay, and then the last element, that's the second row, second column. So I'm going to take the second row here times the second column there. So 3 times 6 plus 4 times 8. So 3 times 6 is 18, and 4 times 8 is 32. 18 and 32 is 50. And that's how you multiply. Okay, let's spread this out a little bit so we can see. Okay, so on this one, it's a 2 by 2 and a 2 by 2, so you check, and yes, you can do it. Okay, I'm going to circle the rows on the left and the columns on the right. So first row, first column. First row, first column. I'm going to take 1 times 6 plus 0 times 0. So 6 plus 0 is 6. Let's go to this one. This is the first row, second column. So 1 times 2 plus 0 times negative 1. So that's 2, and 0 is 2. Second row, first column, negative 2 times 6 plus 3 times 0. So that's negative 12 plus 0 is negative 12. And then this one here is second row, second column. So I'm going to take negative 2 times 2 plus 3 times negative 1. So it's going to be negative 4 and negative 3. That's going to be negative 7. Okay. Let's go to this one. I got a 2 by 2 and a 2 by 2, so I should be able to do this. Okay. And the first thing I always do, and you've seen me do it, is I circle the rows and the columns. Now, I always get this at test time. If people aren't paying attention, they assume that they're just going to multiply the same way they add or subtract. And as you know now, that doesn't work that way. So make sure you're doing that. Okay, so here's what we got. Okay, first row, first column. I got 6 times 1 plus 2 times negative 2. So 6 and negative 4 is going to be 2. First row, second column. 6 times 0 plus 2 times 3. So that's 0 and 6 is 6. Second row, first column. 0 times 1 plus negative 1 times negative 2. So that's 0 plus 2 is 2. And then second row, second column. So 0 times 0 plus negative 1 times 3. So that's 0 and negative 3 is going to be negative 3. I hope that makes sense. All right. Let's do another one. Notice on this one, let's check this out. They're not the same dimensions, but they don't have to be. You look at that and you say, okay, that's a 2 by 2. And this is going to be what? 2 rows and 3 columns. To multiply, the inside 2 have to be the same. And the outside 2 are going to be the dimensions for the answer. So I know I'm going to have 2 rows and 3 columns. So my matrix is going to look something like that. I just put placeholders in there. Okay. Again, I circle the rows and I circle the columns. Okay, let's see what we got. Okay, so first row, first column. So that's 8 times 1 plus 3 times 3. That's 8 plus 9 is 17. First row, second column. So I got 8 times 2 plus 3 times 0. 16 plus 0 is 16. First row, third column, 8 times 6 plus 3 times 1. So 8. So 48 plus 3, 51. Okay, now we're going to go second column times the first row. 6 times 1 plus 1 times 3. 6 plus 3 is 9. First row, second column. 6 times 2 plus 1 times 0. So it's 12 plus 0 is 12. And then second row, third column, you're going to have 6 times 6 plus 1 times 1. So that's going to be 36 plus 1 is 37. And there's your 2 by 3 answer. So it's very similar to, we have numbers. You can add, you can subtract, you can multiply numbers, you can even divide numbers. And we got the same thing going with matrices. You can add them, subtract them, multiply them. I showed you scalar multiplication. One thing you cannot do is you cannot divide matrices. Okay, let's look at example 5. Can we do this one? This is a 3 by 1 and a 1 by 3. Can you do those? Are the inside two the same? Yes. Your answer is going to be 3 by 3. Okay, I'm going to put this answer over here. We can do this. Just imagine we circle the rows over here, and your rows only have one element. Your columns are up and down. They only have one element. So just imagine where the dots are. You're going to have a number for each one because we know the answer is going to be a 3 by 3. Okay, so first row times first column. So 1 times 4, that's all you have to do. There's no addition there. It's going to be 4. Then 1 times 3 is 3. And 1 times 1 is 1. Now we go to the second row. 2 times 4 is 8. 2 times 3 is 6. 2 times 1 is 2. And the third row, 6 times 4 is 24. 6 times 3 is 18. And 6 times 1 is 6. That's your answer. That ended up being a lot easier than we first thought, I'm sure. Okay, what about this one? This is a 1 by 3. This is a 3 by 1. So you look at it and you say, are the inside the same? Yes. So your answer is going to be 1 by 1. That means this answer is just simply going to be one number. So we got one row and one column. We're going to take 4 times 1 plus 3 times 2 plus 1 times 6. That's all one number. So it's going to be 4, that's 6. 4 and 6 is 10, plus 6 is 16. That's a 1 by 1 matrix. I want to go back. You're going to see some other terminology. When I go back to, let's say, this matrix, that's a 3 by 3. When the dimensions are the same number of rows and columns, a 3 by 3 is a good example of it. That's a square matrix. Up here, I had a 2 by 2 and a 2 by 2, and my answer was a 2 by 2. That's a 2 by 2 square matrix. A lot of times they'll call this a unit matrix because there's only one number that's there. Okay. How about this one? I got a 3 by 3 and a 3 by 3. The insides are both 3s. The outside's going to be 3s. So they're all going to be, your answer is going to be 3 by 3. Okay, so I'm going to circle the rows. I'm going to circle the columns. Okay, so look what happens on this one. I know my answer is a 3 by 3, so when I take the first row times the first column, I'm going to have 4 times 1, and then the other two are times 0, so they, anything times 0 is 0, so really you're going to have 4 plus 0 plus 0. My first number here is a 4. Then you do the first row, the second column, so I got 4 times 0, which is 0, 3 times 1, which is 3, and 2 times 0 is 0. So the zeros make everything drop out. So really we just have 3 times 1, and that's going to be 3. And then we go over here, 4, 3, 2 times 0, 0, 1, 4 times 0, 0, 3 times 0, 0, and 2 times 1 is 2. That's going to be 2. Now we go to the second row. So I'm going to take 7 times 1 is 7. 6 times 0 is 0, and 1 times 0 is 0. So I got 7, 0, and 0. That's going to be 7. Second row, second column, 7 times 0 is 0. 6 times 1 is 6, and 1 times 0 is 0. So that's 0, 6, and 0, 6. Second row, third column, 7 times 0 is 0. 6 times 0 is 0, and 1 times 1 is 1. So 0, 0, and 1 add up to 1. Then the third row, first column, I got 0 times 1 is 0, 2 times 0 is 0, and 5 times 0 is 0. So 0 plus 0 plus 0 is 0. Third row, second column, 0 times 0 is 0, 2 times 1 is 2, and 5 times 0 is 0. So that's 0 plus 2 plus 0 is 2. And the last one, 3 by 3, third row, third column, 0 times 0 is 0, 2 times 0 is 0, and 5 times 1 is 5. So 0 plus 5 is 5. Oh, sorry. Here's what I want you to notice. Look at the matrix you started with. Look at the matrix you ended with. 4, 3, 2, 4, 3, 2, 7, 6, 1, 7, 6, 1, 0, 2, 5, 0, 2, 5. They're the same. This, when you take something times something, you end up with what you started with, this is called the identity. That's like if you had the number 6 and you multiply it times 1, and you get 6, I got the same number that I started with. I started with a 6, I end with a 6. So that was the multiplicative identity element. That's what it is in regular multiplication. That's what it looks like in matrices. It's always a square matrix. You got 1s on the diagonals and 0s everywhere else. That's very similar to what we were trying to get when we were talking about Gaussian elimination. If we were talking about addition, if we started with a 6 and we were adding something and we wanted to end up with 6, then that number is going to be 0. If I was adding these two matrices, then the identity for addition, they would all be zeros. So the for matrices, identity for addition zero, 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 zero. They're all zeros. The identity for multiplication is 1, 0, 0, 0, 1, 0, 0, 0, 1. And that's for 3 by 3. Let's just take a second. If we were talking about a 2 by 2, okay, 2 by 2. The multiplicative identity, I should do addition first, but the multiplicative identity would look like this. 1's here and 0's everywhere else. Additive identity is always 0's everywhere. Now, I bring that concept up because that's something that we see quite often. A lot of times I will just say, well, it's the identity. And if I'm saying in that sense, I'm talking about the multiplicative identity. Okay, so this is my last page of notes for this. So let's see how I do here. Many times on a test, if I was testing whether you know the basic operations, what I'll do is I'll give you two matrices. I'll say let A be this one and B be that one. And then I'll give you the problems. You can see here where it says A plus B, 2A minus B, 3A plus 2B, and A times B. So I can get 4 problems in a short amount of work, short amount of area. So whenever you see this, A plus B, in your mind you're saying, okay, all I'm going to do is I'm going to take 1, 2, 3, and 8. That's 8. A plus B, which is 5, negative 1, 2, and 0. And we know when we add, we just go across. So 1 plus 5 is 6. 2 plus negative 1 is 1. This part's easy for you now. 3 plus 2 is 5. And 8 plus 0 is 8. Okay, no problem. That was A plus B. Okay. The next one says to take 2A minus B. So that means you're going to take 2 times the first matrix and then you're going to subtract the second matrix. And now you can organize this however you want to organize it, but I would usually go down. Okay. So this says we always multiply first. So I'm going to take 2 times each of those. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 8 is 16. And then we're going to subtract 5, negative 1, 2, and 0. And we'll put the answer over here. So 2 minus 5 is negative 3. 4 minus negative 1, that's 4 plus 1, which is 5. 6 minus 2 is 4. And 6 minus 0 is 6. Key is just keep yourself organized. Okay, the third one I had was 3A plus 2B. So that tells me I'm going to take 3 times A, so that's 1, 2, 3, 8, plus 2 times B, so that's 5, negative 1, 2, 0. So on the left, I'm going to take 3 times each of those. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and 3 times 8 is 24. Plus 2 times 5 is 10, 2 times negative 1 is negative 2, 2 times 2 is 4, and 2 times 0 is 0. Then you can have 3 plus 10 is 13. 6 plus negative 2 is 4. 9 plus 4 is 13. And 24 plus 0 is 24. And there you go. And the last problem I had over there was just A times B. So 1, 2, 3, 8 times 5, negative 1, 2, 0. So again, we're going to circle the rows. Circle the columns. 2 by 2 times a 2 by 2. My answer is a 2 by 2. First row, first column, so 1 times 5 plus 2 times 2. 5 plus 4, my first number is going to be a 9. First row, second column, 1 times negative 1 and 2 times 0. So it'll be negative 1 and 0 is negative 1. Second row, first column, 3 times 5 plus 8 times 2. 15 and 16 is 31. Second row, second column, 3 times negative 1 plus 8 times 0. Negative 3 plus 0 is negative 3. As you get going, you may not have to show all of this. I made sure I did so you could follow along a little bit better. You'll get to a point where you'll be doing a lot of that stuff in your head and be pretty good at it. The downfall to all of that is, and you're more susceptible than I am, but because I do math all the time, but even at that, sometimes you take things for granted and you still make mistakes. So to avoid the mistakes, I would suggest writing this all out to come up with your answer. You're going to do some things like you're going to take 0 times 5 and you're going to put 5 down there, which is silly. 0 plus 5 is 5, and that's what your mind is thinking, but 0 times 5 is 0. So make sure you get those down there. Also, everything I showed you in this lesson, you can use on your TI 83s or 82s or whatever you got, your calculator. And it's actually kind of neat. Any type of graphing calculator probably has them built in. I'm going to, I'll post it on resources, but I've got another lesson that shows you how to program that stuff in your calculator. So if you wanted to do that, you don't have to. And most of the stuff we're going to do, you can do it just like I did today. But, if you choose to use your calculators, then of course they're there. And it'd be a great thing to use to check your answers as you're going through. That's one thing that's kind of tough. You can't really check your answers very well. Okay, that's going to wrap it up for this lesson. I'll get this posted and we'll see you next time.